Good morning, good afternoon. As introduced, I'm Norbert Funke. I'm the EMEA Product Marketing Manager for Isilon, which is a dedicated business unit within the EMC family. And I will touch base on Isilon a little bit, what it is, where it comes from during the presentation. What I wanted to talk about today is basically key trends, roughly. I guess you know these already, but just to reinforce the key trends we see in the market, which requires a different kind of storage architecture. Throughout the presentation, I may refer to the term traditional architecture, traditional approaches, whereas what we are doing. This is no judgment by no means. Not saying that we are better than traditional architectures or vice versa. It's really depending on the workload, what kind of storage you need for particular environments. So don't think that is a kind of judgment or whatever. No. Traditional architectures, why they don't scale. Scale out. They scale up, but not scale out. I will explain you why that is. It's 2 technical slides explaining this one. A little bit of overview what Isilon is. I'm not talking about the whole history, just to give you a feeling about it. Introducing to this scale-out NAS technology to the boxes, and as time allows, I will talk a particular Hadoop use case where we have some unique strengths as well. Jumping right in. As everybody knows, the data growth we see these days, it's not in structured data. It's really in the unstructured data. It's media files, it's PDFs, Office documents, sensor data, big time sensor data these days, machine-generated data, and so forth. There's the big data growth. It's roughly 80% of the storage we need today. It's for unstructured data or semi-structured data. So that's where the music plays, if you like, and where Isilon is basically specifically designed for. Isilon is not designed for transactional data. You won't use Isilon as a storage platform for databases or for Microsoft Exchange and so forth. It's just for the unstructured data, file-based storage solution. What we do see is that 2 worlds are converging right now. That's where Isilon basically came from. It's called big data. It's a kind of buzz term these days. I would consider it huge volumes of data, where you have petabytes or even terabytes or even petabytes of data. You need to store it in a central repository. That's where we came from. Originally, this company got founded by somebody who was working as a data center engineer for Real Networks. And Real Networks was the first company who wanted to distribute rich media, music, films, and so forth over the internet. In 2001, he had a big challenge. The infrastructure wasn't supporting the business model. He couldn't get, in 2001, he called up everybody, EMC, NetApp, IBM, HDS, you name them, trying to buy storage. Nobody could sell him storage, fitting his demand, this huge demand of data collection of music and films. So he founded this company. He took it as an opportunity and funded this company in 2001. So here's where we came from. But now on the enterprise side, we see the same phenomenon, the same issues, that huge data sets are getting created. There's some customers of ours like Bosch or Jaguar Land Rover who are using it for engineering purposes. Jaguar Land Rover to cut down the number of prototypes. These guys are producing 100 terabytes per week. So even if we're talking about big home directors over there, where for design companies and so forth, not even big companies, but companies generating a huge amount of data. So we see that these basically coming together to what we call enterprise at scale storage solutions. Further, we do see different workloads coming in now. It's not just having the home directories or file shares and so forth. More and more data gets generated by next generation devices like mobile devices, analytics, Hadoop, big data analytics, big times, and the cloud. So we have to have a storage platform which is not just supporting one of these workloads. We have to have a storage platform which is supporting all these kind of workloads, different workloads. Having said this one, when we talk about a storage platform, what is important here? It must be easy. And I will share you what I mean by easy in a second. It must be scalable. This box scales from 18 terabytes, it's the smallest configuration, up to 20 petabyte linear. Efficiency. We can't afford these days anymore to run at a utilization rate at 40, 50, 60%. In case somebody in the traditional world is saying he utilizes his storage arrays up to 70%, I will challenge him. I simply won't believe in him, show you the reasons right afterwards. So it must be much more efficient than we see in the traditional world as we talk about big volumes of data. At 10% higher efficiency, it's big money. And we're talking about 200 terabytes or even petabytes of data, right? And it must be secure. It must be a secure storage platform. So the traditional security measurements we know from the traditional architectures must apply here as well. So no compromise on security. What is Isilon? Again, founded was it in 2001. EMC acquired the company end of 2010. It's the fastest growing business within the EMC. Just to give you a glance, 2010, end of 2010, it was a $250 million company. This year it will be over $1 billion. Think about that growth rate, right? It's a fast business. We have more than 4,000 customers right now. What it means, number one, scale out. 2 slides from Gartner and IDC afterwards. OneFS is basically this software. Our intelligence is not in the hardware. We're using commoditized hardware. No special things on hardware. So the innovation really comes from software, and that we call OneFS is our operating system, if you like. And you see, big adoption in specific vertical markets, healthcare, all these media images, oil, gas, seismic interpretation, and so forth, Web.2, and so forth. That's where this comes from. Why we are who is basically saying we are number one in this market is Gartner. They moved away from these magic quadrants. They now introduced what they call critical capability surveys. They're doing for different kind of technologies, for database collaboration, storage, servers, and so forth. So basically what they laid out, 10 critical capabilities for storage, like scalability, efficiency, resiliency, performance, security, capacity, and so forth. And they're ranking the different storage vendors against these critical capabilities. And you see, we won it basically across the board. Same endorsement we got from IDC. They are not going to so technical as Gartner is doing it. They are more looking at the strategy of the product as well as of the company. What is EMC's commitment behind that business? And it's big. We still maintain our own engineering, product management, marketing, sales, everything. It's basically a company in a company because we think it's such a strategic new area for the company. And capabilities, again, capabilities in terms of what the company puts on the table, as well as those product capabilities as well. They're mixing it slightly together. As you can see, the big bubble, that's us. The pluses and minuses is basically indicating who is gaining and who is losing market share. And the size of the bubble is market share. Don't get confused, it's scale out only. It's not NAS in everything together. These analysts split up scale out NAS from the separate NAS. And it's also interesting, both reports are from this year, beginning of this year. These analysts recognized there's a shift in the storage business right now, which requires scale out NAS. So why does this traditional architecture doesn't scale? Building up a traditional architecture, you have a bunch of hard disks. You apply whatever security, it's called RAID, right? 4, 5, 6, whatever. Then you're basically creating LUNs. Then you're putting a volume, a file system on top of it, some kind of processing power, controllers, and you map your applications towards the storage, hard mapping. You need to assign an application to a particular LUN or file system in LUN. So now you're filling up the infrastructure. How do you scale now? As you can see, here are volumes which have overutilized and underutilized LUNs. How do you scale here capacity? Yes, you can. Manually migrate data off the overutilized LUNs. That's the traditional way. Data center administrators do this, but it's a very, very hard thing to do. requires a lot of labor and constantly monitoring these kind of overutilized LANs. Adding additional LANs and or volumes of file systems to it, it's possible. Again, not easy and takes quite a bit of time to do that. So probably most customers do that one. Throwing away the box, getting a bigger box in place. Adding another NAS device and somehow federate them or cluster them together. It's a possibility as well to scale capacity. Again, it's not scaling fast enough. It's very, very manual labor intensive and gives you not great utilization right, these kind of technologies. How do you scale performance? In case you do have, pardon me? More spindles, yeah. Basically, you get a bigger box, right? So this is not designed for scale out, for big data growth, for fast data growth. When we're talking about 20, 30, 40, 80, we have customers that are growing 200% a year in file-based storage. This architecture is not giving them any freedom. So what we are doing basically, when you're talking to somebody who has on his business card Isilon, don't use the word LAN. He probably wouldn't know what you mean. It doesn't exist in the Isilon world. Or write is another one. Nobody in Isilon knows what a write is. No reason to have dedicated volumes and file systems. Why? Why not scale independently, performance and capacity? So what we do basically, we have one big box, if you like, one big C drive, which scales up to 20 petabytes linearly. So no technology-based constraints for scalability, performance and capacity independently. And storage automation, I show you when we talk about scalability, what we mean by automation. So a single volume spans all the cluster nodes. There's a distributed cluster file system, that 1FS, spans all the nodes together, brings them together. And as soon as you add another node, you aggregate the capacity as well as the RAM, the CPU power, whatever. This gets all into the pool. So you create actually a huge RAM space as well, right? A cache if you like. Again, this is traditional RAID systems, traditional architectures. You have separate volumes, file system, and data protection RAID systems. We group them together. Gives us a lot of advantages, value proposition based on this architecture. We're not RAID-based architectures and LAN-based architectures. Simplified throughput, single file system, very simplistic, simply to manage. Highly resilient. RAID systems can sustain 2 failures. That's it. We can lose 4 nodes. Even one of the nodes has 100 terabyte. Multiplied by 4, we can lose 4 nodes in a cluster. And we still guarantee data integrity. Efficiency, our customers usually run at 80+% utilization, whereas 60 or whatever it will be. On this one slide animated, we are still the fastest NAS box with 1.6 million spec SFS IOPS. Interesting with these kind of benchmarks, normally whatever vendor is ranked number 1 within a quarter, a competitor beats him. This thing is 2.5 years old. Robust data protection, talking about this one, scalability as well. And my favorite is this one, operational multi-protocol support, operational flexibility. As I said, we have different workloads these days. Mobile, cloud, traditional workloads, special applications for specific verticals. They should go on one box. Also, there's a comprehensive enterprise software suite coming with this. So just say we are moving into the big data where we came from, but now we need to add enterprise functionality as well. So snapshot is basically creating snapshots. I'm not going into detail. SyncIQ, yes, it's asynchronous replication we can do. We can't do synchronously. Smart Connect is basically load balancing. How do you connect clients very effectively to the different nodes within the cluster? up to 140 nodes get into the cluster node. Smart pools is storage tiering. Talking about this in detail later on. Deduplication, as of 2 weeks ago, we launched the new version. Now we can do deduplication as well in the file system. Smart quotas, thin provisioning, it's a can set quotas for the file systems or for different organizations or whatever, how you wanted to slice your big 20 petabytes. You can set quotas for project groups or whatever is required. Inside IQ gives you, some indication of performance, utilization, right, and so forth to fine-tune the cluster. From a security point of view, we support the worm data protection so that files can be protected against deletion and alteration. Auditing is also a new feature, so we integrate with third-party auditing tool. Varonis is the first one. Others will follow. We have native integration into these tools. Very important for governments, financial services, healthcare providers, and so forth. They require auditing. And now what we have called encrypted nodes. This actually is encrypted, self-encrypted hard drives, what this refers to. So you can have a whole cluster can have encrypted data. So that's a small overview of the software features. Talking about scalability. Going back, sorry, it was fun. You have in this example a 4-node cluster. You're running through your threshold, 80%, 85%, whatever you're comfortable with, right? So you want to add capacity or capacity and performance. What do? You order a new box, you unplug the box, you cable the box, you rack it up, and in your management console, say, add. It takes 60 seconds. To provision 180, 100, 120 terabytes, whatever fits into a box depending on the size, on the capacity of the boxes, in 60 seconds. I think nobody else can do this, and that's a big advantage because we are not LAN and write based. The traditional architectures you can't scale in 60 seconds. You're not scaling, putting one hard drive into your write class array or LANs in 60 seconds. Not even 4 terabytes, right? Or 1 terabyte. Unique. Auto balance, a very interesting capability as well. Again, a 4-node cluster. Filling it up, it gets full. The previous slide showed us it takes 60 seconds to add another node. What is happening in the background? Again, 60 seconds. The utilization is the same across all nodes. We call it auto balancing. It migrates data of the other nodes to the new node in the background. That's the way how we achieve 80% utilization. There's no need to look for overutilized LANs, underutilized LANs, manually migrate data, or add another node, more LANs, or another node to the cluster, whatever. It's auto balancing the data and eliminating these kind of hotspots, what we call overutilized LANs. Eliminating this one. Moves content automatically. So another term, which is unknown to Isilon people, is migration. This is data migration, right? Automatically moving data. Even think about how difficult today is it to retire a traditional architecture, let's say with 80 or 100 terabytes, to a new box. This is a serious project. This is a serious project. We don't care. We don't care how old these nodes are. In case you wanted to retire these ones because it's 4 years old and you have a tech refresh, just add a brand new one up here. You see it's an auto migration, but still data on there. In this case, you have 2 options, the hard way or the preferred way. The hardware is just plug the power cable from the box. Or you say on a management console, shut down. Both, when you say shut down, it automatically migrates data off this box without a manual intervention. In case you just plug the power cable, it would consider it as a failure. And they would rebuild this data on the other boxes. So whatever you prefer, both is working. So migration doesn't exist, the term. Smart dedup, I spoke it already, which is a new feature we have since 2 weeks. It's basically, it's working like all the other deduplication technologies from all the other vendors as well. It's basically, you have 2 files. There is basically, these are in common blocks, 8K blocks. We look for 8K blocks. And this gets freed up, and basically this file refers to these 2 8K blocks of the other file. That's how we're doing deduplication. We can do a pretest. As it's a licensed feature, you can run free of charge on your cluster a test and see if your data is really suitable for deduplication. So you can do it upfront. And basically other benefits is increased efficiency. It adds very well to our efficiency story with 80+% storage utilization. And therefore, less rack space, power cooling cost, whatever the benefits are of deduplication applies here as well. Improved TCO. I talked about this one already. Availability. What we do, as you can see in the background, these are things, we are striping the data across the hard disks and nodes in the cluster. So we take a file and chunk it up and putting this on different hard disks on different nodes, distributing it, including the parities. And then you can set different data protections. The minimum is data mirroring. But when data mirroring is probably not the most efficient one. So what we have, it's N.1 protection. In this case, you will sustain a node failure or hard drive failure for one only. But this can go up to N+2, N+3, and the number 4 is basically the simultaneous failure you can have without data lost. Again, 4 components, traditional architectures, only 2. And in case you're in a rebuild time in our traditional architecture, and during the rebuild time you get another failure, bad luck. What also is important is the rebuild time. 3 terabyte, 4 terabyte drives are quite common these days. But we increase the capacity of a single hard disk big times. But we haven't invented a new recovery algorithm. We are still using the old stuff. We as well. We haven't done anything here. But when you're in a traditional world, a 4 terabyte drive to rebuild it, and you're not taking this traditional architecture offline, which you probably don't do, it can take weeks to rebuild a 4 terabyte drive, depending on the load. Because we have all the cluster nodes are helping to rebuild this particular drive, not just 1 or 2 controllers. Whatever you have in compute power here is helping this, and you bring this a week down to a day recovery time. So a lot of people forget, putting a high density, 4 terabyte drives into their storage, but don't think about rebuilding in case something fails. And a hard drive fails. How are we doing on time? Okay. Compliance and security. We talked about already the warm data protection. We talked about file auditing is the next slide. We talked a little bit of data encryption at rest. So we can encrypt all the data in the cluster. Current limitation is the whole cluster needs to be encrypted. Today we can say a subset of the cluster. That's a kind of limitation, just as a heads up. This will go away next year, by the way. Role-based access control, role-based administration. Not everybody should do everything on a cluster from an administrative point of view. This is fully integrated here as well. And what we call the authentication zones. This is basically, sliding the cluster according whatever demands are. If there's different projects, if there's different departments, if you share the cluster across your organization with other business unit, whatever you want to do, if you slice it according to your business, your workload, mobile data, and so forth. So you can do this through authentication zones. And nobody else, in this case, IT or marketing couldn't access the accounting data. And you can apply to these authentication zones also, what we call tiering, the smart tiering. So you can, in case accounting data, after a year, you basically, it's not hot data anymore. You want to probably put it on a more cost-effective box as well. So you can do this auto tiering as well. I talked about the file auditing. It's a plug-in, basically. We're having to the event locker, which is integrated into this case Varonis. Out of the box today, we are adding others as well. But for today, Varonis is a market, we consider as a market leader, particularly in the industries where auditing is important, financial services, healthcare, and so forth. So we do this one to do who's accessing the data, who's changing the data, who changed maybe security permissions as well. Security permissions and owner of data. Data migration, we talked about this before. Another big advantage to this auto balancing. You don't lose the owner of the data. You might have noticed when you do traditional data migration from one box to another box, your data owner becomes one gentleman called Mr. Administrator. It's very difficult to migrate the owner of the data in the traditional world. This is not an issue here. This gets only when we're doing auto balancing or automatically populated again, and here who is accessing the data and so forth. Now the portfolio, we are talking about linear scalability for performance and capacity. Just building up the boxes, there's different types of nodes we do have, depending on the workload you want to put it in there. There's the ZS series. It's a kind of high IOPS, randomly accessing the data on the box. In case you have these kind of workloads, it's kind of a high computing performance, high computing environments, like simulation, for instance. This would be the box. The X series is for high throughput. You want to have a big pipe out of the box. Media files, big imaging, medical imaging, and so forth. You probably will use an Xbox. An L box is basically high capacity, lowest dollar for the capacity, basically, high dense, but less throughput, less performance. You get this one. Typically used as a archive or backup target, where you don't have performance, these kind of performance requirements. So putting up here, because a backup is just a big file, right? Basically, put it on here, or in case we talked about the accounting data, in case it's longer, older than a year, whatever, move it automatically to these kind of, boxes. Again, that's basically from up here, reducing the cost per terabyte. We talked about data migration already. It's policy-based. So you say it either on a file, if you can go down to a file level granularity. Probably doesn't make sense, but if you want, you can go down to this granularity. Creating a policy which is automatically tiering off the data from one box which is more expensive per terabyte than to another one, automatically back and forth. Single point of management. There's no different management consoles involved to do this. You have just one GUI, just one web-based interface to do this, or you can do it command line, of course, as well. No application changes. So even you're moving, that's also in your traditional world, right? When you move something off, you need to make the application aware that there's a new volume, new file system, or whatever. No need here. It's just, if you like, in the simplest way, it's just one IP address representing 20 petabytes. That's it. This auto balancing will do the rest. The auto balancing is basically a kind of internal DNS server, which knows where the data is. Very intelligent DNS server. Yeah. Transport reallocation. Yeah, you can move data back and forth as you like. IDC. Looked at the total the cost savings. We saw them, this, storage provisioning, 60 seconds. No data migration, whatever. What does it really mean? Higher utilization rate. IDC says CapEx cost is 40% less than in a traditional world. Operational cost, roughly half by using this kind of technology. I think it's a very compelling thing. High utilization rate. Even, think about this utilization thing and this fast scalability. Another thing is, traditional world, you have a system for 3 years. Then you have a tech refresh. Today, when you order the system, you have to have a crystal ball on your desk to predict how much storage will you need in 3 years' time. That's how you scale today traditional architectures. Because the scalability, as we saw, it's very hard to do. You want to avoid this one, this kind of piece of the daily work, right? So you try to do a prediction. Your data growth and how much additional storage. What is the price drop per terabyte per year? 20, 25, 30%. Why not anticipating in this price decrease? Because the scalability is in 60 seconds. So you buy on demand. That's where these costs are also coming from. Whenever you need a capacity or performance, buy then. It's definitely cheaper than today. This, again, it's for me the biggest value proposition of the Isilon cluster. I recently were on a phone with a customer, ran through all the good things we can do, and then he basically said, Norbert, nice, but tell me just one point where you think this box is unbeatable. For me, it's this consolidation of workloads. I think it's a platform discussion. Wherever you want to start. In case you have a vertical workload, applications in a particular vertical which is creating this file-based data, right? Huge amount of data. Healthcare, medical imaging, life science, next-gen sequencing. Huge thing in the life science and healthcare industry to analyze the DNA of a human body. Big thing. All the hospitals are doing it. It's becoming so cheap these days. A couple of years ago, to do a DNA sequencing was roughly $100,000. In the next 2 or 3 years, all these vendors who are doing this one, saying it comes down to a cost of an X-ray. So it's a huge thing. Medical, that's where it came from. I explained it already. Media and entertainment industry for the different workloads they do, rendering, high compute performance things, as well as distribution. Oil, gas, big times. These guys are scanning the whole world, trying to find new resources and modeling. How difficult it will get to this oil or gas field and so forth. Huge amount of flat data, video surveillance, all these cameras. It's huge amount of files. Retention times, these days is 30 days or even longer. And you have these high definition cameras these days. It's a huge amount of data you're generating here. Or, in case you wanted to start with one of these because of particular requirements you have, why not over time doing the enterprise workload, putting on this as well, the file-based workloads. Consolidation. As soon as you retire, do a tech refresh. Just put it on here. I think capacity is not an issue, right? Home directories. Consolidate all your home directories. You have security, you have full control over your home directories and the data on the home directories. Big data analytics. Huge thing right now. Big advantage. Here, this box, high performance computing. File sync and share. How are the people doing file sharing these days? Usually 3 methods. One is called Exchange. It's not designed for sending out 10 megabyte PowerPoint files, right? A link would be much better. Then file shares. Who has control over file shares in bigger corporations? Nobody. Because these days in a virtual environment, you can bring up a VM in 10 minutes and configure a Microsoft server in there as a file share. Nobody will find this thing. No control over this one. And then SharePoint. SharePoint, well, its design is based, that database is a SQL database. A SQL database is not a data storage repository for file-based data. It's for transactional data. So, consolidate all this one and get control over. as well as backup archive targets, big thing as well. Then this new workload, object and cloud. We do have these. Everybody is using these mobile devices or tablets or whatever. Just, put them on here. We support natively the Amazon cloud, OpenStack, and we have a bunch of, APIs. When you develop your own web-based, cloud-based, or web-based applications, you can put it on an Isilon as well, because we can store objects as well on this one. And isn't it nice to store an object there, accesses via file protocol, and manage the data or change the data? So you can do this. You can have object and file based on one box. Last 5 minutes talking about Hadoop, big data analytics. It's a huge thing for all the industries. We haven't found one industry which is not interested in this one. We saw 80% of the data companies these days store is file-based data. Unless they wouldn't see a value in there, why are spending them, some customers, millions of euros a year to increase their storage infrastructure, in case they wouldn't think there's real value in this file-based data. That's where Hadoop is coming from. But the problem of Hadoop, the challenges of Hadoop, is basically single name node. This is the brain of a Hadoop environment, as it is designed by Apache, which it came from. When this thing goes down, your whole Hadoop environment is down. You don't have access to the data. You don't have access to the results anymore. So you need to bring this one back, which is not easy. Another problem of a traditional Hadoop environment, dedicated storage infrastructure. These are compute nodes which has direct attached storage. You need to put the data, you need to get them somehow in this direct attached storage. Lack of enterprise application. Hadoop does not know backup, replication, whatever we consider as data protection technologies. Hadoop doesn't know this. Storage efficiency. That's the data protection. In a Hadoop environment, dedicated infrastructure, you can't use what you have already, but you need to build 3 times the capacity, because Hadoop is making 3 copies of each file for data protection. And then you have this on a primary store. You actually have 4 times the data capacity you need to have. And we're talking about huge volumes of files, terabytes, petabytes of data. You wanted to have 3 times the storage capacity? Well, utilization for direct attached storage is even worse for what I refer to traditional architectures. What we see, it's roughly 30 to 40% they are running. Scalability, how do you scale this thing? In case you need more capacity, mirror the data 3 times and putting another compute node attached to it, or the other way around. In case you need more compute power, you have to have direct attached storage to it. No scalability at all. Manual import and export of data. How you're getting out your prime data source, which is already there in a data center, data into here. Hadoop doesn't foresee import-export. Good luck. No, interesting thing. Hadoop environments, traditional Hadoop environments, are always out of date, because your data is changing on a daily basis. How do you recognize which data changed in my 80 terabyte centralized file storage repository and get it into Hadoop? How do you recognize it? It's nearly impossible. And it's not a shared infrastructure. You can't use it for anything else. The slide before we saw, the Isilon, different workloads on one physical box, if you like. You can't share it here. What we do, again, unique. Nobody else can do that in the industry. All this data is already there because you collected it through your mobile devices, through different workloads, and so forth. Just enable the Hadoop file system. The trick here, Hadoop file system requires, on the previous slide with this direct attached storage, still a native file system underneath. Linux or whatever file system underneath. So this is actually not really a file system. This thing is much, much better as a protocol And that's how we are using this HDFS file system. We are using our file system under NAS, 1FS, and just as a protocol, there that these compute nodes up here, which can be in a virtual environment, which is highly scalable, a VMware server farm or Microsoft Hyper-V server farm, in case you need more compute power to analyze your data, bring up a bloody virtual machine and put the Hadoop compute component into this virtual machine. In case you need more capacity, we talked about this one, how we scale here. So independent scalability. We support both the old and the new version of the file system. Distributed name node. A name node for us, and how a name node actually is architected, is just a file. It's a kind of database, if you like. That's a name node. He knows where the data is growing and which storage the data can be accessed and so forth. So we can have the same data protection on this box as well. So basically, to sum it up, no single point of failure for the name node. It's protected as the data itself. Shared scale-out storage platform. Scale as your data set grows. Performance as well as capacity independently. Is business data we are talking about. And business data, there should be an enterprise-ready protection mechanism applied to it. Don't run it with 30% or 40% utilization and mirror the data 3 times. Use this box, and with higher utilization, independent scalability, whatever you need a Hadoop analytical nodes, just add it, or capacity as well. Multi-protocol, use this box for different things as well. Hadoop is just one workload for us. It's not requiring a new dedicated infrastructure. Data is stored on primary storage, and in case something changes on the primary storage side, Hadoop knows it and does the analytic on the latest version of a file and not a file version which is out of date, basically. With that, I'm open to some questions, guys. We have time. Please. Otherwise, I think lunch is served already, right? Which may have a better proposition than. Otherwise, I will be around for some minutes as well. Yeah.
How is this related to Insi's Scale.io product?
Isn't it?
Not going to be?
No, that's really future plans. Yeah.
Similar.
It's not really similar. It's a Scale.io. It's more than high performance, more designed for traditional work for transactional workloads. Yeah. So we are just talking about file storage. Yeah, not for big Oracle database. You wouldn't put an Oracle database on top of Isilon. Mm-hmm.
Any more questions for Norbert? In that case, I will thank you very much for your great presentation. We learned a lot about Isilon and scale-out file systems. I think personally it's the way to go. I think it's the future. It's more scale out than scale up. I think it's, yeah. Thank you very much for the presentation.
Thank you very much. All right, thank you.